Now let us move to dependent nested loops. Previously we saw outer loop is running n times and inner loop is running n times, or we also saw just now that outer loop is running n times, inner loop is running m times for each time the outer loop runs. So now we will see outer loop is running n times and inner loop depends on the outer loop. Let's take this for an example. In here we are given an initialization of I from 0, and then this condition if I is less than n, and this increment of this, and inside this loop we are having another loop in which j is initialized from 0. But see this, here we are comparing j from I itself, so this is compared from the outer loop, so the number of times this run will depend on I. So this is called dependent nested loops. Let us do the dry run taking n equal to 3. So first I equal to 0 is initialized. It will check if I is less than n, n is 3, so of course it is less than n, so it will move inside the loop. Inside the loop we have another loop where j is 0. If j is less than or equal to I, yes, j is less than equal to I, it will check once we initiated, and we also compared once that if j is less than I, yes, j is less than or equal to I, because it is equal to I, it will print 0, I and j, which is 0 and 0. Since now if this statement is done, it will go to incrementation, it will increment 1 and j will become 1. Now it will again check if j is less than or equal to I is 0, j is 1, it is not less than equal to I, so this loop will be terminated and we will move here and this will be incremented. So I will be incremented, j will be restarted. First we will check if I is less than n, 1 is less than n, that is 1 is less than 3. So yes, this condition is true. So we will move again inside this loop where we are having another loop. So here also we will initialize j again with 0, and this will be compared again. J is less than equal to I, is j, now j is 0, and is 0 less than 1, yes, 0 is less than 1, so we will print I and j, which is 1 and 0 is. So if this statement is done, we will move to here, increment j, j will become 1, is j is less than equal to I, this condition will be checked, yes, it is less than or equal to I, so we will print 1 comma 1. Similarly we will move, so let's write the similar kind of dry run or similar kind of pattern in which we did it previously. So for example, let's now take n equal to 5. When I will be 0, j will be 0, and this will print only this much. When I will be 1, j will be 0 and j will be 1. When I will be 2, j will be 0, j will be 1 and j will be 2. When I equal to 3, j will be 0, j will be 1, j will be 2 and j will be 3. So and when I will be 4, j equal to 0, j equal to 1, j equal to 2, j equal to 3 and j equal to 4. So we can see for each time I loop is running, for example, whatever the number we are getting for an I, the same amount of time j loop is running. For here we can see like the number of times j loop is running increases one by one. So it is running once, it is running twice, it is running thrice. Now for next iteration it is running 4 times. For next iteration it is running 5 times. For n equal to 4, and now when I will be only 4 itself. So it ran, I already ran 1, 2, 3, 4 and 5 times. So for each time I is running for each iteration, the number of times j runs increases. So we can understand that when n was 5, I ran 5 times. So I loop is running n times only. But there is a catch in the number of times j loop is running, and we will see this. Here j loop is running once, plus next it is running twice, next it is running thrice, 4, and next it is running 5 times. But what if instead of 5 we have n? So it will continue to run 6, 7, 8 and n times, right? If we have n instead of 5, then j loop will continue running till 1, 2, 3, 4, 5, 6 and until n times. So we have a common expression for this type of addition series, which is n into n plus 1 by 2. So we are getting j loop runs this many times and I loop runs this times. So the total time function we will have is n plus n into n plus 1 by 2, which is this plus this. So of course we can get n square here, and this will be the maximum degree of n. So the order will be n square. If you have any difficulty in understanding this, you can try dry running the code, or I will give you more examples in next few lectures. You can try dry running each code and finding out the time complexities. And if you get any doubts, you can also ask in the comment sections. So our next topic is triangular loops, and which is a special case of dependent loops. Here we will see how this loop runs. So let us take this n equal to 2 or 3. Here n is 3, j is here we have a catch that j is not starting from n or 0, but it is starting from I, and the condition is if it is less than 3, which is n. Okay, so now we will start. For n equal to 3, I is starting from 0. Okay, I started from 0. We initialized it. We will check the condition. Yes, it is true. Now we will move inside the loop. We have another loop. J is whatever we have in I. So j equal to I. So j will be 0. We will check if j is less than 3 or not. Yes, it is less than 3. So it will print 0 because it is printing only j. Now after doing this statement, it will be incremented. It will go to 1. If 1 is less than 3, yes, it is less than 3, so it will be printing 1. Now again it checked, and now again it will be incremented to 2. Yes, it incremented. We will check if 2 is less than 3 or not. Yes, 2 is less than 3, it will print 2. It will increase. We will again check if 3 is less than 3 or not. No, it is not. So this loop will be terminated, and we will be again incrementing this I. So I will become 1. So we will start j from 1. Now j from 1, j is 1. Now j is 1. We will again start j from 1, and we will check if j is less than 3 or not. Yes, 1 is less than 3. So it will print j, which is 1. Now j will be incremented. It will become 2. We will check 2 is less than 3 or not. Yes, it is. So it will print j. Now it will increment again if 3 is less than 3 or not. No, 3 is not less than 3. So this loop will terminate, and we will again be incrementing I. So we will again be making I is equal to 2. So now we will again start j from I. With our I is 2, so our j will be started from 2. Now we will check if 2 is less than 3. Yes, it is less than 3, so it will print only 2. And next it will be incremented. It will be incremented. It will become 3. But no, 3 is not less than I. 3 is not less than 3. So this loop will terminate here only. And then we will move to this I. The I will be incremented again. 3 is not less than 3. So this loop will be terminated, and the whole loop will be terminated. So notice one thing. In this case, the number of times the J loop runs is decreasing. When n was 3, first it runs 3 times, then it runs 2 times, and then it ran one time. So when n was 3, first it ran 3 times, then it runs 2 times, then it ran once. So let's generalize it. When n was, let it be n, it will run n times, then it will run n minus 1 times, then it will run n minus 2 times, and similarly till it only runs 1 time. So this is also similar, and this loop ran once, twice and thrice, which is n. So in here we can also write that I loop ran n times and j loop ran just n plus n minus 1 plus n minus 2 plus until 1. So this is also equal to 1 plus 2 plus 3 plus plus till n in reverse order. So this is also n into n plus 1 by 2. So we will add this and this for the time function. The time function will be something as n into n plus 1 by 2 plus n, and here also we can find a term of n square. So the order will be n square. I hope you got this. You can all dry run this code to understand, and I am leaving this for you. This is a pattern question and this will print some good pattern. I hope you can try this running and also dry running this code. Now let's move to another topic, which is logarithmic loops. And the catching part here is that we are not adding or subtracting I. That is, we are not incrementing or decrementing I by addition or subtraction operations. We are multiplying or dividing I here. So whenever we will be multiplying or dividing I, it will be automatically a logarithmic loop, or you might try to dry run and get if it is a logarithmic loop or not. So in here, let's dry run taking n equal to, let's say, 32. Yeah, because here we are doing the multiplication, so let's take n equal to 32, and we are starting from I equal to 1, sorry. So here we have I equal to 1, and now it will print I equal to 1. We are initializing it, okay, and we will check if I is less than 32. Is it? Yes, I is less than 32. So if it is true, this will move to this, it will print 1, which is I. If this statement is done, it will be incremented. The incrementation is just multiplying I from 2, so I will become 2. 1 into 2 is 2. Now it will again check, is 2 less than 32? Yes, it is less than 32, so it will print 2. Now this will be incremented again, so 2 into 2 is 4, and now is 4 less than 32? Yes, it is less than 32, so we'll be printing 4, and this will be incremented, it will become 8. Is 8 less than 32? Yes, 8 is less than 32, so it will print 8, and 8 will be incremented. Is now 8 will be incremented to 16. Is 16 less than 32? Yes, 16 is less than 32, so it will print 16, and 16 will be incremented to 32. So now is 32 less than 32? No. So here we are terminating this loop. So how many times this loop ran? You can see once, twice, thrice, fourth, and 5 times. So this loop ran 5 times for n equal to 32, and here I was 2. So can we derive a relationship from here? I guess we can. So we can see this loop as number of times, or how many times we can multiply 2 before reaching 32. Isn't it the same? like this loop ran 5 times, which is same as how many times we can multiply 2 before reaching 32. So we can get a simple logic here, which is log 32 base 2 is 5. Yes, so this is how we can get here. Since the log term is there, you might think, why are we taking log term? Because logarithm is also kind of a successive multiplication, so, or successive division, which is the same thing. So here log 32 base 2 is 5. So now let us do this example using the same formula or same concept, and let us understand why it is coming as log, why log term is coming. So let us take n equal to 64. This will be 64. We will be starting our I from 64, so I will be 64. Is I greater than 1? Yes, I is greater than 1, so it will be printing I. 64 will be getting printed. Now 64 will be getting decremented because it is I is getting divided by 2, so I will become 32. Then 32 is greater than 1. Yes, so 32 will be getting printed. Now it will be decremented again to 16. Is 16 greater than 1? Yes, so 16 will be getting printed. It will be decremented to 8. Is 8 greater than 1? Yes, 8 is getting printed. Now it will be decremented to 4. Is 4 greater than 1? Yes, it is, so 4 will be getting printed. Now it will be decremented to 2. Is 2 greater than 1? Yes, 2 is greater than 1, so it will be getting printed. And now when we will increment it, the last one again, like when we will decrement it again, it will not satisfy this condition, and this is the number of times the loop ran, which is n times. So once, twice, thrice, 4, 5 and 6 times. So the loop ran 6 times. Is there a relationship? Yes, 2 power 6 is 64, and we can write it as log, like this is n, right? 2 power 6 is n. We are getting 2 power 6 is n. So we need 6 as an output and n as an input, because we need the n size, n as an input size. So we can just do the log thing, and log base 2 n is 6. So it is of the order of log n. I hope you understood it. So this will also be of the order of log n. Next we have linear logarithmic. Linear means the order will be n, and logarithmic means the order will be log n. So we'll just multiply these. Here we can see this loop. We have already run it many times. This loop runs n time, and for each time this loop will run, this loop, which is j into equal to, like j equal to j into 2, will run log n times, just like this one. This one here we saw, this one, this loop also was the same pattern of incrementing, and here this loop also has the same pattern of incrementing. So this loop will run log of n times whenever this loop will run once. So the total will be n times of log n, and this will be greater than, so now the order will be n log n, because this is bigger than this. And you can try dry running this code again, and this will sharpen your concept. This question I am leaving it to you. Please comment the answers in the comment section, and I hope to see correct answers. Now we have this topic, multiple functions. We saw one function. For all this time we were seeing just one function, which is either we are making any number of code, like even if it is nested or anything. This was all under a single function. So this was n. So this function, if this loop runs n time, this function also will run n times. This is the simple concept. Now we have multiple functions. For example, this we have a bigger this is a function. Let's wait a second. Yeah, this is a function. This is function 1, this is function 2, and this is the main function. So as we can see, we have already done this kind of loops. This run n times, so this will also run, this function will run n times because the content of it is running n times. And similarly, this will have order of n, and this is running n times, so this will also run n times, and it will also have the order of n. Similarly, this is the main function, so it will also have order of n because this has both the functions, which is O of n. This has O of n, and this is the order of n. So both having 2 times order of n, which is, we just discard the constant and it is still order of n. Now this is an important question to understand. This has n, this loop runs n time. This will also run n time because it's this function's content runs n times. So this will also run n times, and it will have the order of n. Okay, and this, see this is running n squared times. So this will run n squared times. So this will also run n squared times, and it will have the order of n square. So now we can see function 1 has the order of n, and function 2 has the order of n square. So in this concept, we will learn a concept later called the growth of functions. And whenever we get to choose what is the correct order of the function, like if we are adding these two functions, but there is one function which is more dominant, which is this. So the time complexity will be order of n square. The total time complexity of this function will be order of n square. But why did we not consider O of n? This we will learn in the concept which we will learn later called growth of functions. Growth of functions, and we choose the function which grows more faster. We can see this by a graph. The n, order of n, or the n has a linear growth, whereas this n square has a greater growth. So we only are interested in this region where n has this growth and n square has this growth. The larger growing function is n square, so we are taking n square. And here also, like, the larger growing is n square, so we will be taking n square. Here the larger growing is n, so we will be taking n. And here the larger growing is O of n times of log n. We are choosing the one which is growing faster. We will see this concept in next few lectures. And I guess let's end it here because recursion is a little too long. We will do this recursion in next lecture. Thank you and happy coding. If you have any doubt, you can put it in comment sections.